What's up, guys? This is day 43 of the Pglo lab, molecular genetics, yeah. So today we're working on this graph. It's on a logarithmic scale, so it looks kind of weird and funny, but it's gonna work out. So what you're gonna do is you're gonna use the data from this side. Now, I told you guys yesterday, the data is off 1 decimal place. So where it says how far the DNA traveled, you need to move the decimal over 1 to the left. So it should say like 1.1, 1.6, 1.8. And then on the graph, the DNA that you're going to be determining something from, you also need to move it over a decimal place. So it should be like 2.0, 3.45, 3.6, 0.6, 1.7. Does that make sense? So make sure you move the decimal over on all those. But basically what we're doing today is, on the graph is, you've got a set of DNA, which is your standard, okay? So keep in mind, when you put DNA in a gel, it's going to run through the gel. And the longer you leave the electricity on, the more it's gonna run through the gel, right? So in order to figure out how big the DNA is that you have in the gel that's moving through there, you have to have something to compare it to. So the standard is like the known comparison, okay? So that's the one that you're graphing on here. And so you're gonna put the distance it traveled, and then you're gonna plot a point, and then you'll use that and how big it is and plot a bunch of points. And once you get those points plotted, you're gonna make a smooth curve from it, okay? And so that is what you're gonna use to figure out how big your other DNA segments are. So for instance, on that previous page, it's got DNA 2 and it's got DNA 1, okay? DNA 2, the first segment traveled 2 centimeters. Remember, move the decimal over. So it traveled 2 centimeters. So how are we gonna figure out how big that DNA is?
Find where 2 is on the...
Yeah, so all you do is find 2 on the x-axis. You go up, and where it hits the line, you'll go over, and that'll tell you how many base pairs it is, okay? So it's a way of using that standard to figure out how big those other segments of DNA are. So you're using something that's known, and the unknown, you can figure out how big it is from that, okay? So you'll do that for all 5 strands there that are given off to the right. How big are those strands in base pairs, okay? You should be able to get pretty close with that. And like I said, I know that graph's small, but if you'll take a straight edge, or we'll get you a ruler out of the back or a piece of paper or something, it'll make your life like a million times easier. All right, the big moment. Yesterday, the transformation lab, you did all that work. You took your bacteria, you took your plasmid with the Pglo gene for fluorescence. You mixed them together, you heated them up, you cooled them down, all that jazz. And in an effort to get those bacteria to take up that DNA and transform, right? So, I want you to look at this sheet on the lab. It's the one with the 4 circles, and it asks you some different questions. What type of agar was in this petri dish? Did it contain ampicillin? Were there bacteria present? Was the plasmid there? Did they glow in UV light? And you had to explain a couple things. Did they glow? Why or why not? Were there bacteria present? Why or why not? So you're going to do that for all 4 samples. Now, what I want you guys to do is, if you will give me, take a picture of yours. Somebody take a picture of what theirs looks like, and then we'll post that in the discussion section, maybe just 1 person from each group. If you'll post that on the discussion section for day 16, the people at home can use that information, okay? So here's how the order I want you to go in though. So let me slide this over a little bit. So you people at home kind of have an idea of what we're doing. So we had 4 petri dishes. In those petri dishes, we had some different stuff. In petri dish 1, we're gonna let petri dish 1 be the LB negative. So it had what in the agar, in the gel? It had LB, which is
It's like that
broth, a nutrient solution for bacteria to grow, and it's negative because
it doesn't have Pglo.
It doesn't have the Pglo gene, okay? What do you expect should have happened? Now, if something didn't happen on your plates that should have happened, I want you to make note of that. This is what I saw. These are our results, but this should have happened, okay? I'm not going to count off if something didn't happen, but I do want to know, I want to know that you know what should have happened, okay? So these questions have come up before on the AP exam, and so if it comes up again, I want to make sure you know what's happening. So, what should have happened in that LB negative?
It shouldn't have been.
What? Will there be bacteria or not?
There will be bacteria.
Okay, there should be bacteria. And when you're looking at bacteria, saying are there bacteria present or not, there's 3 different things you could put. 1, no. 2, colonies. Colonies are little dots of bacteria, okay? Because that means you have one bacteria that started to grow into a colony. So if you see a colony, that's one original bacteria that grew into that colony. There's probably millions there now. And then the other option is lawn. Lawn means like you smeared your bacteria all over the plate and then they're all growing. And so you basically got the whole thing covered like a lawn, okay? So, and you should be able to tell that it's kind of like it'll have like a smeared appearance where you did that. And so, yes, that's what you should expect for number 1. No, but like I said, you need to focus on what you had. Number 2, with the LB and the AMP and negative, what's on that in that petri dish?
You have the broth.
You got the broth to grow bacteria. You've got AMP, which is ampicillin, which is a antibiotic. Okay, antibiotics kill bacteria, and you've got negative, which means what? No plasmid. Now remember, the plasmid had 2 important things. It had the Pglo gene for fluorescence, so it would glow, and it had an ampicillin resistant gene. Okay, so in these negative petri dishes, you did not have the plasmid mixed in with the bacteria. Okay, so what do you expect to have in number 2? No growth, lawn, colonies. Okay, we'll see. Number 4, we got LB amp and we've got positive. So you've got broth, you've got ampicillin, okay, the antibiotic. You've also got positive. Positive means, what did you have in there? You had the Pglo plasmid mixed in with the bacteria. So what do you expect to happen in that one? Lawn, colony, nothing. No growth? What do you expect to happen? Why colonies, Katie?
Because I don't think, I mean, they can grow in it because they are resistant.
What's it gonna take for them to grow in it? What had to happen? Mason?
Then they're taking the Pglo to become immune to the antibiotics.
So the original starter plate that you had, that you grew bacteria on the first day, you took those bacteria, you exposed them to the plasmid. So in order for them to grow on this plate here, that has ampicillin on it, which normally kills bacteria, those bacteria would have to take it in, right, and take in the plasmid. So transformation rates aren't super great. Some are going to do it, but probably a small percentage of the bacteria you actually expose to it. So you are probably right in that you would expect to see colonies growing on that. Okay, and they'll just appear as little dots. If you see a lawn on there, I'd like to see that because something strange may happen. Now, it could be very well that you have nothing on there, which means what? It didn't transform at all. So now, I had, out of 5 groups this morning, 1 group didn't have any transformation. So the other 4 groups did. So we're going to see how you guys did. So I was really worried that this wasn't going to work because we poured the plates really thin and they kind of got dried out on the starter streaks that y'all did. But turns out it worked pretty well. I think there were maybe 1 in this class that didn't work, and I think maybe the other 2 did. 1 was probably one of the best ones I've ever seen in terms of number of colonies on a plate. So I'll show you guys a little bit. Number 4, we've got LB, we've got ampicillin, we got the broth, we got ampicillin, and we've got 1 other ingredient in there. What do we have in the gel?
The sugar.
We got the sugar arabinose. What would you expect to happen in the 4th petri dish? What type of growth?
Yes, colony.
Why colony?
Because at this point it has more nutrition available to it, but
It's not really more nutrition. The broth is nutrition. The sugar is needed in order to express the Pglo gene. So in order for it to fluoresce, it has to have that sugar. It's not really a nutritional thing for like growing more bacteria though. I don't think it's not significant. So what would you expect? You expect something to glow? Colonies or lawn? Which one? Do you think a large amount of those bacteria are going to transform? Like all of them, where you have them growing all over the place?
colonies, because there's no real real indicator that the transformation is going to be varied in any way.
Okay, well, we're gonna find out. All right, we'll video and see. Boom! Look at that, lit up like a Christmas tree. Well, that's disappointing. The other two groups didn't have any, but I guess you guys made up for it.